Hi. Okay, today we are going to learn about using integrals to find the area under a curve. So we just learned about something called Riemann sums, right? And Riemann sums rest on the theory that you can split up an area into very thin rectangles and evaluate the limit as the width of each rectangle, aka the delta x, approaches 0, and as the number of rectangles n approaches infinity. As we sum all of those rectangles together, we end up evaluating the area under the curve between A and B using an integral. So if we're trying to find the area under a curve and it's bounded by the x-axis, it's super easy to find, right? We just find between A and B. What about when curves get a little funky, right? What about when curves have areas both above the x-axis and below the x-axis? Well, area under a curve is always going to be measured as something positive, right? So how do we account for the fact that there's going to be a negative part and a positive part? Well, if you just went right ahead and integrated from, let's say, 0 to 8 along this curve, right, you would end up getting a positive area, and you would end up subtracting that negative area below, and that's not giving you the total area. That's giving you the green area minus the red area. But what we want is kind of like the absolute value of this area plus this area. So there's two things that you can do in an integral in order to account for the fact that areas below the x-axis will be negative. And the first is to subtract negative areas. So using this picture that's right over here, right, you will see that this integral is naturally split up by its roots, right? Between -1 and 2, we have a positive area. And then between 2 and 3, we have a negative area. So we're going to have to do some math magic here to figure this out, right? So what you're going to do is you are going to split up this integral, right? So from -1 to 2, I'm going to take that positive area that's yielded by the function x cubed minus 4x squared plus x plus 6, and I'm going to subtract the negative area from 2 to 3 because that will inherently give me the absolute value of that area. Why? Because minus a minus gives you a plus, right? So if you look in a calculator, right, I already typed this in for you so I don't waste your time. Okay, so look, I have from -1 to 2, right? I typed this in the calculator and I found the area to be 11.25, right? Then I typed the area from 2 to 3 in, and it ended up being -0.58333. But I know that I'm going to have to take that absolute value, so 0.5833, and I'm going to add these two together. So this is why subtracting negative area works. Look, when I have 11.25 minus that minus area, right, that -0.58, it ends up being a positive 11.833. So that's one way that you could do it. Split up the roots and subtract negative areas. Split up the roots and subtract negative areas. The other way you can do it is take the integral of an absolute value. Now think about which method is going to lend itself to like the one that you choose, right? So when you subtract negative areas, this can be done by hand. This is how you will solve all integral problems where this like crops up on the part 1 of the exam. When you take the integral or absolute value, right, that is going to be for part 2 questions. So you just type in from -1 all the way over to 3, and your calculator will do the work for you. We don't know how to calculate absolute value integrals by hand yet in this class. You actually don't learn it this year. So this method is only useful for you when you are taking part 2 of the exam. So on the calculator, you type in the integral under absolute value bars. And that will do the work for you. That's for part 2 questions on the exam. Okay, so let's go ahead and do this example problem number 1. Like I used its picture, so we already know what the answer is going to be, but that's okay. I'll show you how we would calculate it by hand, all right? So it says find the area enclosed by f of x equals x cubed minus 4x squared plus x plus 6 and the x-axis. So as you can see from -1 to 2, right, we would have x cubed minus 4x squared plus x plus 6 dx, -1 to 2, minus the negative area generated from 2 to 3 of x cubed minus 4x squared plus x plus 6. And you would go ahead and integrate those and then subtract them, right? So you would end up integrating and you would get x to the fourth over 4 minus 4x cubed over 3 plus x squared over x plus 6x, and your bounds of integration will be from 2 to 3. You are then subtracting that negative area to kind of find its absolute value in a roundabout way, right? Minus okay, minus the other guy being integrated, so we got x to the fourth divided by 4 minus 4x cubed over 3 plus x squared over 2 plus 6x. He is being integrated from -1 to 2, okay? So if you did that guy by hand, you'd end up getting 45 over 4 minus -7 over 12. This becomes 45 over 4 plus 7 over 12. This becomes 71 over 6, which is approximately 11.8, which is what we found on the calculator. Hello, there it is. Okay, yay. Okay, we're the best. Let's go to a little bit of a sneaky snake of an idea, right? So it says we have areas between curves, right? So when you have the area between two curves, you're no longer bounded by the x-axis, but you do inherently have a top function and a bottom function, right? And the way that you would find the area between the two curves is by taking the top function and subtracting the bottom function, right? If you're trying to find the distance between two things, you take the top thing, you subtract off the bottom, you find the space in the middle, right? That's exactly what we're doing, but we're doing it with integrals. So it's saying like you could just do the top minus the bottom and write it as two different integrals. Or in this case, you can just write it as one plane integral, right? You can just go from A, the first point of intersection, to B, the second point of intersection, and you just do the top function minus the bottom function, and then just integrate with respect to x between those two. Okay, cool. So let's do an example of that. You're going to find the area between y equals x cubed and y equals x squared minus x between x equals 0 and x equals 1. So it gave us our intersection points, 0 and 1. All right, cool. So I'm setting up my integral, right? The area between the two curves would be found with bounds of integration from 0 to 1. And we're going to do top function minus the bottom function. So the top function here is going to be x cubed, right? He's the top function. Pew. Hello. Minus the bottom function. Make sure you put the bottom function all in parentheses, otherwise you're going to mess up the signs. All right, cool. So now you would just integrate. Okay. You'd end up getting x to the fourth over 4 minus x to the third over 3 plus x squared over 2. We are integrating between 0 and 1, so we would end up getting 1 to the fourth over 4 minus 1 to the third over 3 plus 1 over 2 minus everything with the 0 would just be 0. So we would end up getting 5 over 12 as the area between those two curves, okay? Notice how you don't need absolute value. You don't need to mess around with that kind of stuff because the area between the two curves is just going to be top minus the bottom. Now, there is one sneaky little thing that could happen when you have a region between two curves, and that is the graphs swap places. So, like, look at this picture here, right? I have blue being the top function all the way until we get to, let me give you like a little thing to trace by. Here we go. So I have blue being the top function all the way until we get to 0, and red is the bottom. So if I were to find the area of that space, I would do the top, 1/2 x cubed minus 7 over 2x plus 3 minus x plus 3. And then the graph swaps places at 0, And then now the blue becomes the bottom and the red becomes the top from 0 to 3. And the way that we would reflect that here is you integrate from -3 to 0. You do top minus bottom. Then you integrate from 0 to 3 and you do top minus bottom. Notice how they like switch spots. So you have to switch who is getting subtracted, and then you could just add those two together. Okay, that's it for now.